Deep learning sounds complicated, but the core idea is actually pretty simple. It's just one way computers can learn from examples, a technique within machine learning, which itself is a part of artificial intelligence. At its heart, deep learning is just math functions, nested within other functions. Modern neural networks can contain billions of mathematical connections. We call these layers of functions a neural network, because they're very loosely inspired how brain cells connect to each other. Here's how deep learning works in practice. You show the network lots of examples. Let's say you want it to recognize cats in photos. The network starts by making random guesses. You tell it when it's wrong. Then, when it's guessed wrong, it adjusts its internal math slightly. After seeing thousands or millions of examples, these small adjustments add up, and the network gets better at spotting cats. The deep in deep learning means we stack many layers of these functions. Modern networks can have hundreds of layers, each with specific roles. Maybe the first layer is simple edges and colors. The next layer could be basic shapes. Deeper layers would be more complex patterns, faces, objects. Final layers could be complete scene understanding. And this is actually similar to how our own vision works. When you see a cat, your brain isn't following a set of rules like, if it has pointy ears and whiskers, then it's a cat. Instead, your brain learned from seeing many cats and developed its own internal pattern for recognition. This simple idea has revolutionized modern technology. Your phone's face recognition uses deep neural networks to create mathematical models of facial features. Large language models use trillions of parameters to understand and generate text. Self-driving cars use multiple neural networks processing multiple video streams simultaneously. Medical AI can detect certain cancers with accuracy comparable to, or exceeding, human experts. But deep learning isn't magic. It has clear limitations, too. For one, it needs large data sets, often millions of examples. Also, it can only learn patterns that exist in its training data. They don't truly understand things like humans do. You can easily fool this function with carefully crafted changes to inputs. This is called adversarial attacks. But what makes deep learning special is how it scales. As we give these networks more computing power, more data, more layers, they can learn increasingly complex patterns. Taking deep learning to the next step, researchers are now working on making deep learning more efficient, so requiring less training data, better at handling unexpected situations, making them able to learn more like humans do, and using less energy and computing resources. So, deep learning is a powerful pattern matching tool that's really good at finding relationships in data. And while it might seem mystical, remember, at its core, it's just layers of math functions, learning from examples.